Okay, let's continue with our problem. So let's check our kube-proxy pod. And as you can see here, it is still in crash loop. And let's log, get it a log. So log again. As you can see here, still have error to create the sublet manager. Still timeout to this cluster services. And if we telnet from here, yeah, so nothing going on here. So let's open another worker load window, and let's check. So this virtual listener port. So here on the worker load interface, we have this interface. That is a dummy interface set up by the IP virtual server for the kube-proxy mode, and this is the virtual listener IP, virtual IP. So since we are telnet to this virtual IP with port 443, maybe we can run some TCP down on this interface and see what's going on. Okay, let's run some TCP down. Without any filter, and let's see if there's any packet. The telnet, yeah, telnet is still going. Nothing here. Okay, let's see. What about this dummy interface? That it has some relationship with this guy. Okay, let's dump on the dummy interface. So our telnet is still going on. Yep, nothing here. And we do have the virtual listener here. As you can see, this is a virtual listener. This is our master node IP on the secure kube API server. So what if we run TCP down on the master node with this on the interface with this master node IP? Okay, let's run TCP down on the master node. Yeah, our master node. So this is the interface on our master node with the master node IP here. So let's run TCP down on this interface. See if there's anything going on here. Say port 6443. Well, there is some packet going on. but it looks like for a collection already established. See, there's a push flag with yeah. So, but our problem. Let's try again. Start the telnet again. And can we see anything going on here? Let's yeah, so it's like a packed push and egg. So it's for collection already established. But our problem here is we can't even establish a TCP three-way handshake. And on the worker load, we don't get any packet. So what we can do? Okay. So let's go to the basics. Telnet, this local virtual IP, and a port. So what's the packet path on this worker load? Maybe we should get to know how the packet actually flow in a typical Linux box. Okay, so I already have something for you here, which is this guy becomes handy. So this is a packet flow in let filter and general Linux networking. This is a very good network diagram, and to show you the packet flow in Linux. So, but when we run the telnet on a Linux or on the worker node box, so what's the packet flow decision made here? So which is the one we should look at? So yeah, so from this outside, this is a outside packet ingress to Linux. So since we're running telnet locally on the worker node, it should be the packet should be locally generated and not from outside of the box. So not here. So this, by the way, this is the input path. This is input path, forward path, output path. So if we look at a forward path, do you see something interesting here? Here it says local processes, local process. So our telnet is a can be a local process, and then it will generate some kind of packet, right? Okay, so if we follow this path, here, okay, we gotta make a routing decision. So okay, so do we have routing this route? Okay, let's check the route. Okay, check the route. Since the virtual listener IP is a local IP, so we don't need any route for this guy. But what about the route to the master node IP? What about the route to this guy, right? What if we don't have a route to this guy? Okay, let's check. IP route get to the master node IP. Yeah, we have a local cached route. Since our workload IP is 7293, this is the master node is 7298. They are in the same subnet in the node for the node network. So yeah, we don't need a route. They are in the same subnet, and they should be able to connect to each other. So that's not a routing problem, right? Okay, let's go back to the diagram here. So routing decision, then go into the output. This raw with green is the IP table, the raw table in the net filter framework. So there's the output chain here, and then followed by contract. And Mango is a Mango table to actually modify the packet header. Yeah, so still it has output chain too. So this is a raw table here, Mango table here, and come down here, reroute check, some internal reroute check, and then NAT table here, then the filter table here. So this all go through this is all the net filter packet path for a local generated packet. And then it comes down and branch out to Mango post routing. No, it can go here too. So we don't have a routing problem. So here we have a raw table, Mango table. So how we can actually trace this packet in this IP table, net filter framework? Yeah, so maybe we need to find something on how to trace packet in the net filter. Actually, I already have that for you, which is a link here. Explains how to trace IP tables in Red Hat CentOS 7, which is what I'm running. So this is a useful link. Okay, so know the kernel module net filter log, and then set the net filter log value, then enable kernel logging in rsyslog, and then restart the rsyslog system control, restart rsyslog. Then check the raw tables. Okay. So we will want to add our tracing rules before the existing rules. So we should add a rule in the raw table to trace to the destination port 443. Either in the author's case, he's tracing destination port 80, but I want to trace destination port 443 in the raw table and in the output chain, because we are in the, I want to trace right here after the routing decision, right? So the raw table output chain, and we can put a tracing rule here and see what's going on after this or in this output chain. Yeah, we can do that.